In this video, I'm going to review how to graph and how to write rules for translations and reflections. So we're going to start with translations. This first example, they want you to graph the given transformation. And if we look at our directions, this just tells you every point that you start with, you're going to move it this direction. So x plus 4 means I need to move all of my x values 4 units to the right. Y minus 2 means all of my y values need to go 2 units down. So if I take this first x value and I move it 4 units to the right and 2 units down, gives me my new x prime there. I can do the same thing for every single point. W goes 4 units to the right, 2 units down. V goes 4 to the right, 2 units down for V prime. Y, 4 units to the right, 2 units down for Y prime. And then I connect my new points. Now notice your shapes did not change. The only thing they did was shift. So my new image is this one here. Translations are probably the easiest to graph because all it is moving every individual point a certain number of units right or left or up or down. The next example, you're going to actually write the rule. Now, when you get these, you're going to have translations, rotations, reflections, and dilations all together. So part of writing your rule is telling me what kind of transformation and then what it's doing. So if I look at this first example, you want to find your pre-image and pick any point. So I'm going to start with J. J is moving 1, 2, 3, 4 units to the left and 1 unit up to get to J prime. So the way I write that out, if I have to write the rule, I'm going to start with saying it's a translation. Now again, I know that's all we're doing right now, so you would think, well, do I really have to write translation? But you do, because these are all going to be mixed up. I start with x, y, and then what do I do with each of those? Well, x moved 4 to the left, so I represent that with x minus 4, and y moved 1 unit up, and I represent that with y plus 1. Now, if I did have all these mixed up, I'd want to check each point to make sure everything's doing the same thing. T went 4 to the left, 1 up. C went 4 to the left, 1 up. B went 4 to the left, 1 up. So that confirms that that's my rule. The next example, they want me to find the coordinates of the vertices of the image after the given transformation. So I start with my ordered pairs, and I'm going to minus 1 from x and minus 2 from y. So when I do this, I'm going to do exactly that. Every x value, you subtract 1. And every y value, subtract 2. So these are my pre-images. My new image, -1 minus 1 gives me -2. 2 minus 2 is 0. For B prime, 1 minus 1 is 0. 5 minus 2 is 3. And then C prime, 3 minus 1 is 2. 2 minus 2 is 0. So that would be the ordered pairs that go with my new image. So now let's look at reflections. You want to write down the general rules of what to do with your ordered pairs for reflections. When I reflect across the y-axis, think this is your coordinate plane. This is the y-axis. If you are over here and you end up at the exact same point over here, you are just changing your x value. So reflection across y-axis is changing the sign of the x value. When I reflect across the x-axis does the opposite. So when I reflect across this line, if I start up here and I end up down here, what changed? Your y value changed signs. On the next problem, when you reflect across, the next rule, y equals x, well, these just change directions. They change location. So what I mean by that is if you had a point, let's say we had 2, -4. Well, if I reflect across y equals x, your x becomes -4, and your y becomes 2. They just change. Your x and your y flip. When I reflect across y equals -x, it's going to do very similar to this one, but they also change signs. So let's say I had -4, 2 to start with. The 2 becomes the x, but it also changes signs. The 4 becomes the y, but it changes signs as well. So those are the rules for all of my reflections. So let's look at just writing a rule. If I look at this, most of the time with reflections you could tell by looking at them. But one other thing you can check is the orientation of your points. So what I mean by that is the order of the letters. On the pre-image, if I go clockwise, I start with X, then go to L, F, C. Well, find X on your new image. I don't go from X to L, I go X to C. So the orientation of your letters changes. All right? So then you also want to figure out what kind of reflection. I know it's a reflection. And this one is clearly across the x-axis. My next example is reflected across this line. So this one is a reflection. Remember, with rules and writing rules, I said you've got to tell me the type of transformation. So it is a reflection across the y-axis. And then we'll look at across x, y equals x, and y equals -x. This one is the same across that line. And this one is the same across that line. The easiest way to think about this, I know they're both reflections. Think about which one has a positive slope, which one has a negative slope. This one has a negative slope, so it's across y equals -x. This one has positive slope, so it's across y equals x. So if we apply those rules with ordered pairs, we want to write a rule. You want to look at your new ordered pairs and see what's been done to these. So if we look at all the x values, they did not change at all. So look at your y values. Change signs, 0 doesn't change signs, and this changed signs. So you're going to think about which rule tells me that just the y value changes signs. Well, that's going to be a reflection across the x-axis, because remember our rule that the y value changes signs across the x-axis. Let's look at the next one. X changes signs, and then your y's stay the same. So this is going to be a reflection across the y-axis, because only the x value changes. In the next example, when we look at the x values, those are totally different numbers. So I know that it's not a reflection across x or y. So I look across. Those are the same, same, same. These are the same. So x and y have flipped. So the rule that when x and y just flip is reflection across y equals x. Versus the next example, those flipped and changed signs. Flipped, change signs. Flipped, change signs. So the one that tells us that is a reflection across y equals negative x. In the next video, I'm going to go over dilations and rotation, so make sure you watch that video as well.